Now we want to look at a related topic, which is the composition or the analysis of compounds. For example, water, H2O. We could use the periodic table to come up with the molar mass. We would find the value for hydrogen, multiply by 2, the value for oxygen, multiply by 1, and we're going to get an answer of 18.02 grams per mole. If I asked you what percentage of water is hydrogen, the percentage by mass that's hydrogen would be the mass of the hydrogen divided by the mass of the total, which is water, and then multiply by 100%. Well, we know from our calculation the mass that the hydrogen contributed was 2 times its value from the table, 1.01 grams per mole. And the total was 18.02 grams per mole. Then multiply by 100%. So if you do this math, you'll get that the percentage of this by mass, that's hydrogen, is 11.2%. You could do the percentage that's oxygen the same way. Or you know that the total, if you only have 2 elements that make this up, the total has to add up to 100%. So the percentage that's oxygen will be the rest, 88.8%. Now, a percent like this would be a useful conversion. If they told you that you had 20 grams of water, how many grams are oxygen? So how many grams are oxygen in 20 grams of water? We could use the 88.8 as a conversion factor. Remember, a percentage means out of 100. So 88.8% could be written as 88.8 grams of oxygen per 100 grams of the total, which is water. So 2 units lets us convert back and forth again. And I'm going to use that conversion factor here to turn grams of water into grams of oxygen. For every 100 grams of water, we have 88.8 grams of oxygen. And when you multiply this through, you'll come up with 17.76 grams out of the total 20 grams that are from the element oxygen. Often we'll do this in reverse because we won't know what the compound is. If we don't know the formula of this compound, we want to figure out what the formula is. We want to turn the percents into a chemical formula. So here's the setup of a typical problem. You can analyze a compound in the lab without knowing its chemical formula. In this case, we get 15.77% by mass is carbon, 84.23% by mass is sulfur. We want to know what is the simplest ratio between carbon and sulfur. That's called the simplest formula, or it's also called the empirical formula. And you're going to go through the same 3 steps when you have a problem like this. Step 1, assume you have 100 grams total. You could choose a different amount, but the nice thing about choosing 100% is whatever the percent of the element is, the percent is automatically the same as the number of grams. Step 2, turn those grams into moles. And we know how to do that. We're going to use the periodic table. We're going to calculate the molar mass. And then step 3 is simplify those moles to whole numbers. And those whole numbers are the subscripts in the chemical formula. So in this example, 15.77% carbon is, out of 100 grams total, it's going to be 15.77 grams of carbon. And our 84.23% sulfur is 84.23 grams of sulfur if we had 100 grams total. So that's our starting point. Step number 2 is convert those grams into moles. So we need to turn grams of carbon into moles of carbon. And the periodic table tells us every mole of carbon is 12.01 grams. When you work a simplest formula, an empirical formula problem, what you want to make sure you do is carry a lot of decimal places at this step. You don't want to round this number too much. So I'm going to use a whole bunch of decimal places, and that's my moles of carbon. I'm going to do the same thing for the sulfur. Sulfur has a different molar mass. One mole of sulfur, 32.07 grams. So my moles are 2.626442. Step number 3 is simplify those moles to whole numbers. And the way that I'm going to simplify those two is divide by the smallest number. So I'm taking both of these numbers and I'm going to divide them by 1.313072. And when I do that, obviously the carbon is going to turn into just 1 mole, and the sulfur is going to be 2.000 moles. So remember, those moles that we're getting, those whole numbers, are the subscripts that we need in the chemical formula. So I have 1 carbon for every 2 sulfurs, which I write as CS2, which is the chemical carbon disulfide.